floor is yours. You can start.
Thank you very much, Raffaele. And before I start, I would like to ask, have you prepared some UFRO presentation? Or should I do that? If you have the possibility, I would appreciate if you could do a short UFRO presentation before we start, while I'm telling us a little bit about how this webinar should be.
Okay, I will do it. Don't worry.
Great, thank you.
Okay, so
yeah, please go ahead.
Okay, so for everybody, IUFRO is the International Union of Forest Research Organization, and it offers a global network for voluntary cooperation. The network is open to all individuals and organizations dedicated to forest and forest product research and related disciplines. IUFRO aims to contribute to achieving the Sustainable Development Goals set by the United States. IUFRO is a global not-profit, not government, and not discriminatory organization established in 1892 with headquarters in Vienna, Austria. It unites about 650 members organizations in more than 120 countries, representing over 15,000 scientists. 70 meetings are held on average every year, and the IUFRO World Congress takes place every 4 or 5 years, and the next one will be in Sweden in 2024. You can join any of the 10 scientific divisions, over 50 research groups, more than 180 working parties, and 10 interdisciplinary task force. So get in touch with any of the almost 700 voluntary coordinators of this unit. Thank you. Ola.
Thank you very much, Raffaele. So welcome everybody. Here we are still having people joining us, and you are warmly welcome.
Please
as you come
to Zoom meeting.
And Saulo, could you please mute your microphone?
Yes, sorry, Ola. There was some folks on the Google Meeting web link, and I'm telling them to move to the Zoom meeting.
Yeah.
Sorry.
That's good. That's good. So welcome everybody, and I guess we will have a bunch of more people coming in from the Google meeting then. This webinar is consisting of 3 presentations, out of which I will start. After that, there will be Erik Daren from Combitech, and then we will have Saulo Guerra. And these presentations will focus on automation in different kind of forms. We have mine and Saulo's presentations looking at individual forestry machines and what they can do, and then we have Combitech looking at other applications in forestry, and hopefully maybe also some cooperational aspects of how machines could work in the future. So it's going to be a very interesting webinar. And the format we use is so that the presentations are given after each other. And when you have questions, you write them in the chat. And then we will come back to the questions after the presentations and distribute them to the presenters accordingly. So please write your questions in the chat as we proceed with the presentations. Angela, is there something I have missed or should say before we start with the presentations?
Oh, that's perfect, Professor. We can start the presentations.
Thank you. So I will start with my presentation then. And just for you to know, I didn't choose this to go first when I'm moderating also. It was somebody who told me to do it in this order. So I will be talking about developments in autonomous forest harvesting operations and looking at both the precision planning part, but I will focus on the autonomous execution part because that is what you might have seen less of in this business. So just a short context to set this up, that in digitalization and automation in forest operations, has been a lot about kind of jumping on the boom to have more and better data, and that is to improve the planning and the execution, of course, in terms of different support. And this is things that help and complement or even replace the work of the operators. All this data and the improved planning can help operators execute the operations better, or in the really advanced versions, it can also replace the operator. So all these kind of things are valid for normal onboard operations all the way to teleoperated or semi-autonomous operations, and as we will see examples of here also, autonomous operations without any humans involved in the actual execution of the operations. So looking at these two distinct parts, just to understand what are the really differences here, I have divided into precision, it's called pre-planning. And that is a planning based on sensor data, and it has been added some functionality computed from the data. What can we use, what can we emphasize from this data? And this can result in decision support for operators. And it also gives input for the so-called pre-planning of automated operations, a plan how to do it. And then we have the autonomous execution, and that is the operations done without any operator input. And this requires also data, but it requires different kind of data that can be used from the pre-planning, because this requires data in real time and with a very high resolution in order to be useful for the autonomous execution. So you can put it like this, that precision pre-planning, it improves the automation, but it is not necessarily required for it. And the autonomous execution, it must be able to be managed without the pre-planning, but it is of course much improved if we have some kind of pre-planning. And if you compare this with some kind of human context, you can compare it with a human driving with eyes closed, just trying to remember where to go based on a map, a pre-plan. And that would be the pre-planning then. And you compare that how it is when you do it with your eyes open, but without a map. That would be the autonomous execution, but without pre-planning. So you see the difference. There's also the complexity in the differences there between the pre-planning and the execution part. So if you take first briefly the pre-planning, there is a lot of examples of that around now because of the data we have. And I take some examples from some of my own research and some other areas also. And that is computer vision, motion planning, and motion control is what you need in robotics. And in the pre-planning, it's mainly focusing on computer vision and motion planning. And that is needed, the information is needed for knowing the position and the status of the components of the machine. It's needed for the knowledge of their own location, the location of the machine then, and what's around the machine, and also the plan how to execute the work. So these kind of elements are needed and used for pre-planning, and as I said, can be used for a human operator to get support in the decisions that need to be done, or it can also later then be used for a machine to take all the decisions. And one of the key issues here could be, for instance, as you see here, the computer vision, how to identify objects in forestry. In some cases, it's very easy when you have nice and good conditions. It's easy to see trees and ground and stems and so. But in many cases, our forests aren't that easy to distinguish. If you have these kind of conditions, it's difficult to see what is a stem and what is branches, etc. And it can also, at least here in the north, it can be even worse, like when you have snowstorms coming through and the sensors can be clogged with snow and snow covering the objects on the ground, etc. So these are really challenging, but it's developing, of course. Then we go to the autonomous execution, what is not so much worked on and what we will see examples on in real applications here. Then we go to the more motion control part of the robotics. And of course, the computer vision and the motion planning is needed. But here it is a new element also introduced, and that is the motion control to really actually do the movements and the work. So that is real-time control, and it's replanning of the pre-plans if there are such, and it's based on the feedback on how the movements are performed, how it's doing. And here you come to actions as basic as moving around in the forest and to execute the work. And I will just briefly touch upon moving around in the forest because that is quite common in other businesses also. And there is questions then about navigations, where to go, and trafficability. How is it possible? If it is possible to go in certain places? And there is also different principles of how to do the movements. You have some examples here of both walking machines and climbing machines that could be alternatives to wheels or tracks and such things. But this is happening quite much in other businesses also, and we have many examples. So we will not focus on that in my presentation here, because we will go more to the execution of harvesting work, and that is involving to also use some kind of actuators in robotic language and cranes in more forestry language. And that is what is commonly used to cut the trees, to convert trees to logs, to handle the logs, and transporting logs is not necessarily done by cranes, but it's involving cranes to load, etc. So, and we have in my group worked with cranes for more than a decade now, from different kind of simulations to desktop models, and now lately also on full-scale cranes. We have worked previously also on full-scale cranes, but now it's in more this kind of platform. And the platform you see in the picture, it's what we call in Swedish terrängfordonsplattformen. It translates to terrain vehicle platform, and that was a project we initiated together with Luleå University of Technology, Engineering University, and together with them and student projects, this was initiated almost 10 years ago, with first making the blueprints for the machine and then eventually building it and now having it fully functional. And it's a platform for research on mobility, computer vision, actuation, etc. And it is possible to teleoperate it or to have it fully automated. It's medium-sized, if you would call it like that. It's weight 10 metric tons. And it's more or less conventional components in it. It's naturally sensorized, but many of the components are such that you could also find in other machines. It has a diesel engine. It has a proclaimed drivetrain, and it's not really the one you might expect in a forest machine based on it having pendulum arms and hydraulic hub motors, but it's no special components in other cases. It has a Cronab forwarder crane, also a conventional one that can be bought, which has sensors built into it. And some of the sensors used in the automation we will see here is stereo camera, Z2 stereo camera, and Leica Icon 80 GPS system. And more than that, as I said, it's sensors in all joints and so on. And I'm not really the person to answer really technical questions here, because there is a lot of other people who are more involved with that. But if there are such, I will try to answer them as good as I can. Otherwise, I will just refer you to the people who can give you really good answers on those things. And there is also a publication here with some of information on the machine, and there is more to be published later on. And you also see the name IUFRO here, and that is the newly branded name we have for the cooperation here on this platform and on this research. Also, we have been working together for a long time, and now we branded this laboratory to have a kind of a name for it. So up until recently, we have had development part by part, so to say. So this is some pictures to see what kind of work has been going on in the crane control department. Here is pictures to the left where the crane is moved without smart flow control system, and then you see the smoother movements in the smart flow control. And this kind of systems is really important for this platform, because the crane is really big compared to the vehicle. So if it's not really adapted, the machine would more or less tip over or be very difficult to drive if you couldn't have these smooth movements. So this has been going on for a long time, but we wanted to push it. So we set up a target this winter to have a full demonstration of autonomous work. So to actually bring all the parts together, to have the navigation, to follow a path, and to have the vision system to find logs, and to have the crane system to load logs working together. And for that, it needed to be developed some kind of distribution system to coordinate all of these actions. And we managed to do this. It was a really tough work to get it done in time. So you will see some demonstration in the video here, but you can also remember that this was really pushing it. And there is quite a bit of improvements to be done, of course, to all of these aspects, but I will show you what we did and talk you through it. And here you see the machine moving. So it's planned to follow a path, and it has a stereo camera in the front looking for logs. When it finds a log, it stops to get a better position, finding, okay, the log is there. saving that position and then continue moving. It doesn't have any other sensors. So now it doesn't see the log, but it knows how long it should be driving to be in a good position to be able to pick up the log. So it's basically blind now. It's just remembering where is the log. And now it's okay, now I've driven far enough, it stops. It will lower itself to be more stable when it loads. And the crane starts moving to the position where the vision system found and positioned the log. So the crane movement is now located in the where the log is expected to be, is closing until it feels the pressure of the log, and then it just loads to a position behind the machine. It doesn't know where the trailer is, but it is adapted to be letting go of the log where the trailer is expected to be. So if it would be in a turn, for instance, it would miss the trailer in this setup. And then it continues and looking for logs until it reaches an end point. So this was done and was very well repeated when we had the demonstration for 100 people here in Sweden. It was pouring rain and it was successful even in these conditions. So the system is robust in that aspect. The challenge is, of course, to find the logs. So the computer vision need to be trained quite a bit for finding the logs, and to do that in conditions other than this would be requiring quite a bit of research also. Here is really good conditions where you have rather flat ground and you have white logs that are giving good contrasts, but it was very successful in just showing that the components can be successfully put together. And I will stop. These videos are available online, so we will not see a second loading, but I will tell you what is next here. And first of all, you need to remember that this is not a prototype. This is not how we see that the future forward will be looking. This is a research platform. So this is to try and to develop the functionality. And this is a very early proof of concept. We had the demonstration on a Wednesday, and this was first successfully done Tuesday evening. So as I said, we're really stretching it to get this going. So every part in this can and will and need to be improved. It's aspects as navigation in terrain. It needs to be developed further. We need to develop the vision system and to have it on, or at least for the crane, to be able to adapt and to really see the log when it's grappling it. And that could also be used to unload, of course. And then, of course, there is applications on developing this further so it can be able to do harvesting operations, etc. And addressing this to an international audience, we have quite challenging conditions in the Nordics here. So maybe the first application and the real work would be in tropical plantations, where you have maybe easier conditions with flat terrain and trees that are straight and easy to find, and logs that can be easy to find, etc. So we will continue to work on this, and we'll be demonstrating more along this time. But for those who want to see this in real life, I would encourage you to visit IUFRO World Congress in Stockholm 2024, because then we will show this and it will be much further developed at that time, of course. And these people are the ones who are really the engineering people who are now currently on field trials together with master students to do experiments and collecting data for publications regarding to this. And if you want to have more information, there is a rudimentary web page. You also have a YouTube channel where you can find some videos on these demonstrations, and we will upload more eventually. So that was my last slide, and I had to rush it, of course. We have a lot of presentation. There is a lot of things to say here, but I would be happy to hear from those who are interested in these things. And with that, I will turn to the next presentation, and that will be from Erik Daren, who is head of division at Combitech. And as a member of Combitech's leadership team, Erik leads the division of digital and management, where Combitech leads clients through the digitalization journey and Industry 4.0 programs. And Erik mainly serves clients in industrial, mining, and maritime segments, but also cross industry and digitalization strategy broadly. Prior to Combitech, Erik's background includes about 10 years at Accenture Strategy and about 10 years at Toyota, where Erik has held various roles in automotive and industrial equipment sectors. So warmly welcome, Erik, and the floor is yours.
Tack så mycket. Thank you very much, Ola. Can you hear me? Okay. Can you hear me?
Yes, we can hear you. Sorry.
Okay, good.
And we also saw your presentation. We see your presentation well now.
Perfect. Well, a great presentation, Ola. Thank you for sharing. It was very interesting, and I think we might follow up with a couple of discussion points afterwards. Thank you for having me and Martin, from also my colleague Martin from Combitech to present here. We will try to give a little bit of a flavor of how things we work with autonomous solutions in different other industries. So before going straight into that, and also Martin will introduce himself a little bit later. Combitech, for those who don't know it, we are a Nordic engineering and management consulting company with about 2,000 people. We do work a lot in digitalization and cybersecurity and other technical areas. And the one field which is very common for us is industrial settings, like you mentioned, Ola, in the introduction, with typically collaborative autonomous solutions for different industries, and that's one or two of the examples that we will talk to here. I will not talk too much about Combitech because I know the time is precious, so we will go straight into this presentation. And let's start with an example. And the way what we want to talk a little bit about here is how our clients work with autonomous solutions, and talk a little bit about one first example here, which comes from the mining industry, and that will be maybe one of the main focuses, and then we will also touch upon some others a little bit more overview level. So this example is where one of the world's leading iron ore mining companies called LKAB, known in the Nordics at least, by no way as big as the big ones in the world, such as Vale and so on, but very strong position in the market because of the quality of the iron ore in the Nordic conditions. So LKAB had a big challenge to reach to lower levels of mining. So their current mine on about 1,500 meters depth, and needed to find ways to work on 2,500 meter down. And in doing so, it simply becomes unfeasible to transport people and for that matter, fuel and diesel up and down, as well as the goods. So they realized if they're to invest in new depths, they need to find an autonomous and fossil-free production system or a way of basically mining at that depth. So they realized they need to have autonomous operations in the mine, so the blasting and the loading and the blasting and the sort of the mining equipment moving out the rubble and then the iron ore from the mine, but also transporting it up, but also the whole infrastructure around it to become autonomous and electrified, and the control systems as well to manage all that. And what they realize they're talking about is a collaborative autonomous solution where they needed to be able to work with different operators, different vendors, different machine manufacturers who can be autonomous together, so to speak. So somewhere there, the partnership of sustainable underground mining was created, and Combitech's role in this is to be the facilitator of the partnership, but also one of the engineering suppliers into this. And what we actually supply, for example, is the management system to control the autonomous vehicles on the ground. But anyway, the objectives of the partnership was to build a solution which is 50% more productive, which is totally fossil-free or CO2-free, but also sets a world standard for underground mining that could be of interest for all other underground mines in the world in the next step. So basically that's very interesting for the manufacturers, of course, for the OEMs to be able to take this solution to other mines. And LKAB set out to 3 years ago started this program, set out to first prove this system, build this in a test mine to prove that yes, we can work in this way, it's technically possible, and then to implement that step by step in the various mines. We are now at the stage where we are proving this concept in the test mine. So we are currently today operating a setup where, in this case, both Epiroc and Sandvik, who are two equipment manufacturers, competing Nordic equipment manufacturers of yellow machines, they both have autonomous equipment in the test mine and they work autonomously together. So you will have an Epiroc machine autonomously going, picking up material, driving back and loading it onto a Sandvik machine who can take it to the next step of the process. So it's true collaborative autonomous. And also in some cases, it goes straight onto the manual work as well. So it's an integrated machine to machine, but also machine to manual process. So this is, of course, the first stage. It has many, many more stages to come, but it's working right now, and it's something that will be expanded upon. One way to make this happen is the Open Mine Integrator, which is the integration platform where the two, all the different providers in the system can integrate and collaborate and develop collaborative solutions on an integrated integration platform where, and this is something that an independent partner such as Combitech hosts. So if you're an equipment manufacturer, you can work into this integrator and you don't have to show all your APIs and your codes and your specific secrets to all the other partners. So this is a very important enabler for this, to be able to technically collaborate in a sort of a black box for the other people, but we are owning and managing in that on behalf of LKAB, so to speak. So there's a couple of messages in this. We are having already today a real collaborative autonomous operation and actually in production, because this mine also produces goods. It's not only test and production. It's got equipment from different vendors, and they are collaborating on the technical integration platform. Just to talk very quickly on how this was made possible, and to make it short, this is a partnership. Nobody could have delivered this on their own. So I guess the message on this slide is more that to tackle this, it's no point really to build autonomous solutions only with one company, because you will be, it's a bit like the telephone. If you only have one telephone, you have no use at all. If you have two telephones, you can at least call each other. But if you have 3, 4, 5 telephones, then you can start making things happen. And it's a bit same here. So we needed a partnership. We've spent a lot of time to form and shape and work with this industrial partnership. And to be able to get there, we've had to work a lot with sort of, the picture you see on the screen is sort of illustrating a vision, working with things like this, images like this, to make sure everybody interprets this in the same way and reaches the collaboration levels that are needed, so to speak. I will move a little quickly here. I can share the material with the group afterwards, but of course, to make this happen, we have worked out together in the consortium a lot of different tools or methods or structured capital to actually be able to work together in an industrial partnership. But I'll come back to that, and I'll leave the floor to Martin to continue to talk a little bit more about autonomy as a concept and also in other industries. So Martin, please, if you'd like to introduce yourself and speak, I will run the presentation from here.
Okay, thanks. Can you hear me?
Yeah.
Go back one slide, one click, Erik. So I'm Martin Wright. I have a long history within the automotive business, and before Corona hit, I was actually the chief product manager for one of Volvo Trucks' 3 major autonomous projects, the one which focused on confined space. So I have a pretty good understanding of autonomy coming from mining as well here. But one thing that was really apparent when I spoke with when we started talking with customers and what can be done within the autonomous field, it was always the same thing. All the focus was on the autonomous vehicles. That was the key to everything, and they are pretty cool, and that's where things are happening. But one thing that I learned kind of the hard way was that okay, so just one click, Erik. Suddenly, when you start going autonomous, if you're in a confined space or if you're in traffic, you suddenly have a lot of non-autonomous vehicles to also consider, and you had personnel and you had site infrastructure as well. And Erik, you can I think make 3 or 4 clicks because it's actually coming. Yeah, stay there. And suddenly we also realized that well. It's not only autonomy, it's autonomous vehicles. It's really complete system because you also need to think about things like can we be hacked? Can someone take over operations? Do we need remote operations? Can we do all the use cases without any intervention from a human? How do we control the vehicles in the best possible way with fleet management? How do we integrate with all the other systems that are present on the site? And how do we communicate between the different vehicles and the overall system? And last but definitely not least, if being an OEM of an autonomous vehicle, how do we make sure that not only the vehicles fulfills the safety standards of ISO 26262 functional safety or machine directive? How do we make sure the whole site actually does it? How do we make sure that the whole operations can fulfill it? So autonomy is so much more than just autonomous vehicles. It's a complete system, and you need to apply systems thinking from start. And another thing was that it's definitely so that autonomous is not just one solution fits all. It's about if you're especially in confined space areas here, you do a number of different use cases. Some of them are extremely fit to become autonomous and can be automated without any intervention at all. Some will require maybe checkpoints or even remote control of the vehicles. So that was one thing to consider. And finally, combining everything into a complete system makes it so much more vulnerable. Only if you think about all the different things that can happen in the ODD that you set up, the operative design domain, multiply all those error things, and you will not get a lot of uptime unless you are really good at managing the overall productivity of the system. And then for us, one of the major things that we found was that functional safety was one of the barriers to productivity. So we needed to find quite interesting solutions to how can we make operations safe but still productive. For the forestry industry, I think one of the key challenges, I love the pictures that you showed, Ola, before, because a forest is, you can most likely find some really nice forests where the stems are just perfect and the ground is more or less level. But in the Nordic, where I go out in the forest, there's a lot of impediments and rocks and marshes and everything. So it's really difficult for sensors to see through dense under vegetation. So we have a bit of a tricky area to when we're trying to automate this. But just to give you an example of the system thinking, one area that we are working with, if you take the next slide, is harbor operations. This is a pretty neat confined space operations, and for greenfield operations, you can make one part of the harbor autonomous, and the other one you can have vehicles coming in for being loaded and unloaded. So you don't need to have mixed traffic. But if you go for brownfield operations, where you try to make an existing harbor autonomous, that's typically not the case. But just to give you a hint of what you see when you come to an autonomous harbor, if you want to make it, if you don't want to use the AGVs that use transponders, but really try to make it more of a bit of an intelligent system. You will have some kind of a central mission or a central hub where you have the fleet and mission management. Click again. You'll need simulation and site planning. This is true, just as true for a harbor as for mining, and I would also expect that to be true for forestry, where with the pre-planning that Ola talked about before, you can definitely increase productivity, and you can find the best way of running operations. And click again. Also, then of course, remote driving. So if you have remote drivers, they will be sitting somewhere here. Some other things that you will for an harbor, you would most likely set up a private communication network. In a forest, I think communication might be a bit tricky, but you will definitely need it. And if you're going for teleoperations, then in a forest, of course, you will need to have pretty good bandwidth and low latency, and that might be a bit of a problem here. Positioning for shore, and we can click, if we just continue clicking here. Being able to integrate multiple brands, personal safety, if you have personnel being out in the same area. There's a lot of good technology that you can use to increase safety for personnel, like sensors. So you can have both, you can use both the object detection of the vehicles, but you can also have individual safety sensors that can be pretty fail-safe. And worker safety monitoring, of course. And then finally, any potential infrastructure. I don't think that is just as relevant for forestry, but for a harbor, you will have all the cranes and you will have passages that you want to integrate with, and if you click 3 more, just know what this is. That's the one. You'll have monitoring and fences and signals that you need to integrate to as well. And as I said before, one of the really challenging areas is the overall functional safety case. Safety standards for autonomous operations is extremely strict, and the more people or you have in the zone that you are not able to provide with technology, or that you're not able to train, the harder the case is going to become, for sure. Can I take one more? Cybersecurity. There have been attempts to hack vehicles, and so far I haven't heard any accidents reported yet, but this is an area that needs to be carefully thought through from the beginning. And 2 more. System adaptation and integration, and of course we have the luxury here of working with something called Navlink, which is we get times for vessels when they will be arriving, so we can set up operations according to their arrival times. So this is just a quick case from an harbor. If you have any questions, or if you want to know more, for example, about mining, then we have a lot of information about what the challenges are and how we can round some or find solutions to some of them. So if we try to connect what we said now about different autonomous systems, and also what Erik presented initially when it comes to the collaborative partnership approach, we think that creating a fully operational and productive forestry solution, autonomous forestry solution, this is definitely something that will take both time and be pretty complex. Just trying to use our learnings that we have from the mining industry, we see that there is definitely benefits to be made if a consortium was created where typical competitors could maybe partner up with landowners and production companies to see and identify the solutions that could be like the minimum viable products taken to market initially. Because I guess that you all want to see products becoming available on the market. The demonstrator stage is extremely interesting, but when you find the first product on the market, that's when you can start making money of it, of course. So collaboration. is most likely the key. And our question back to you would most likely be, what would such a team look like for forestry? Which would be the main actors, and how could this be taken a step forward? And I'll hand back to you, Erik, for a quick wrap up.
Thanks, Martin. Very good. The last quick minute here. So just a few examples from the mining industry and the harbor industry, the importance of the collaboration approach to make this industrialized. We are talking here about not development, just bringing together what exists today, but actually bringing together what comes in the technology roadmap for the manufacturers in 2, 3, 4, 5 years time, and thinking through if 2 or 3 or 4 partners roadmaps in 3 years time happen, how can those things be integrated together to meet the future needs? So it's a step after the demonstration. It's a step which is extremely complex, but getting it right will be extremely attractive for both the operators like the forest companies, but also for the equipment manufacturers. Thank you. Super quick. Any further questions? We have our email, so we can reach out. I don't know, Angelo and Ola, if we have time for questions now. Otherwise, we'll hand back the stage to you.
Thank you very much, Erik and Martin. And I hope you can stay with us, because we will have questions after the next presentation. And for you who are listening, we will be happy to have your questions in the chat, and then we can post them. I see that there is some answers already from my colleague in the chat here on some detailed questions regarding the machine I was presenting. But please post your questions in the chat. Or Erik, are you hanging with us? Are you with us for some?
Yeah, for sure. We will remain for the full meeting. Yeah, thank you.
Yeah, great. Thank you. So thanks for a very good presentation and some very good insights on the steps after getting the machines autonomous. There is a lot of things to think about, and it was very good to see what we can draw experience from other applications. So we'll come back to that, I'm quite sure, in the discussion then. But with this, we will turn to the next presentation. So Erik, if you stop sharing, please, we will give the floor to Saulo Guerra. And Professor Saulo Guerra is a forest engineer and a PhD from Sao Paulo State University. He's professor at Agriculture Science College at Sao Paulo State University, UNESP. He's coordinator of the Laboratory of Agroforestry, Biomass and Bioenergy, LAB. He's the Bioenergy Research Institute, IPBN. And he's also the current scientific leader of the cooperative program Forest Mechanization Automation at the Forest Research Institute in Brazil, I guess. And he's also the deputy coordinator at the IUFRO Division 3 Forest Operations and 3.10, I would say. And he's a director of UIN, the UNESP Innovation Agency. A lot of abbreviations here, Saulo. If I miss something, please compliment. And the floor is yours.
Thank you, Ola. Can you see my presentation and hear me clear?
Yes, we can do.
Okay, thank you. It's a lot of abbreviations. It's very, very common in Brazil. But thanks for the introduction and the presentation of my brief summary to the audience. I first of all, I'd like to thank you, Angelo, and you for organization for this IUFRO meeting. And I come today to show you a little bit of the automated eucalypt planter that is running right now in Brazil. So we brought this information and we were running those research and field evaluations inside the cooperative program of forest mechanization and automation. This cooperative program aims to increase the productivity with the high standards of quality and silviculture operations in Brazil. So we focus here in planting mechanization and mechanization of silviculture operations and precision forest. Maybe in the future, Ola, we can have your robot in Brazil, as you mentioned on your presentation. So maybe we will have a chance to run your robot and the tropical planted forests and we expect to see maybe in 2024 or 25 your solutions in Brazil, and then we can add the robot technology on our research line. We also work with the development in partnership with different forest companies and manufacturers on the development of a forest tractor, also on the automated tree-line irrigators, and what we're gonna see today, the automated triple line planter. Our program, as you know, Ola and some of the folks already know, the strategy of our Forestry Research Institute is a place where we have the university side, the forestry industry, and companies, forestry manufacturer, machines manufacturers, implement manufacturers, and we have the triple helix on this Forest Research Institute. And in our case, we have established a partnership with 10 forestry companies, and representing these 10 forestry companies, we have four people, actually from CMPC, Senibra, Suzano, and Brazil. We also have an executive coordinator and an assistant to lead and to bring to you technical bulletins, full evaluation reports, web news, online status, and when we had a chance, we will go back to field days and demonstrations. And for you to know, this is the actual scenario for planting in Brazil. Most of the area is still manually planted here for eucalypt and pine plantations. One guy like this, one labor, is capable to plant 1 hectare per day with manual, without any mechanical device, or with some mechanical device. If it's not manual, and manual for us represents roughly today 65 up to 85% of the total worked area, and you will see this later on my presentation, we move one level up and we go into the semi-mechanized planting. And this is just one illustration of a very common implement that is typically used in Brazil for semi-mechanized planting. And in this solution, we have one labor here in front of the tractor, driving the tractor, and one guy behind sitting on the implement. And those two guys are able to plant and sometimes prepare plants, and sometimes also prepare, plant, and irrigate the soil or the ground up to 3 hectares per day. So we shift from 1 hectare per day up to 3 hectares per day, moving from the manual to semi-mechanized planting. And a few years ago, we started to think and to evaluate the mechanized planting systems in Brazil. So luckily we have a partnership, or we had a partnership at that time with a Swedish company that is Brachy Header, and you already know this solution in Europe and in China and sometime Indonesia. And we brought this solution, and with the John Deere manufacturer, we established a new solution for Brazilian planted forest, where we had the Brachy Header planter with fertilizer buckets, is a big deposit, and an extra water reservoir mounted on an excavator. And luckily we had a chance to plant more than 200,000 seedlings and evaluated more than 20,000 seedlings one by one on the ground. And with the forestry company, we were able to provide information to the manufacturer, and the manufacturer create and develop two different solutions for Brazilian, for the Brazilian market and for the globe. And using that technology, we were able to go up to 1.5 hectares per day with 2 labors. And that is real operational field performance. And that is the newer header that was the second phase of our evaluation. And that was an evolution of the original OEM Brachy planter head. And this unit, you have a higher or a bigger carousel with more seedlings on it, the capability to plant and fertilize at the same time, and also you can add water during the planting operation. So with that said, we had the chance to be, or to have, or to follow the first semi-mechanized or mechanized planting operation in South America with irrigation and fertilization at once, add to georeferencing position. But then we move to the third phase, and the third phase happened with the Komatsu manufacturer, the Komatsu tractor manufacturer, and they brought a solution with the 3 planters at once. And instead of using an excavator, they mounted the triple headers on a boom, on a front boom. In this boom, we were able to install those 3 headers, 12 seedling boxes, and we were able to run close to 600 seedlings per cycle. And this tractor, this crawler tractor, drags a 7,000-liter water tank with more seedlings to refill the automated triple planter. And luckily, we were the first one to see in the world this machine running in a semi-autonomous mode. The machine is capable to run on the ground without the human interference, stop, plant, irrigate, and move to the next planting site position without any technology, but any human interference. But prior to this, we need to have a very nice soil preparation. We have to have a deep soil, a deep subsoiling operation with GPS and georeferencing system to create the path, to create the map for the triple planter, follow and precisely position the seedling on the following operation. So in our case, we are using a Komatsu bulldozer, the 85EX. It's more than 200 horsepower. It's close to 30-ton tracked tractor. And we are using a Savannah subsoiler, 3.5 meter between roll and georeferencing system developed here in Brazil with Hexagon. And the Hexagon guys developed the controller in a partnership with Komatsu. So we have right now the autopilot system customized for the triple planter. And also this controller drives the hydraulic flow, the moving of the tracks, and driving the planting heads on the go. So the operator right now only needs to realize the maneuver at the boundaries and lift up and down the upfront bar when the operator see, for example, a big stump or a stone or some obstacle that could not be controlled smoothly by the Hexagon controller. And we are using the real-time extended, the RTX, with the 5 centimeter accuracy for this machine. So the planter itself, using this top view, has 3 heads, and the head itself is capable to adjust itself sideways up to 50 centimeters to the left or to the right. So even though sometimes the GPS could fail, or if you have to a small relief or small detours on the ground, the machine itself could adjust each header to plant properly in line according to the pre-map operation. The data I'm showing to you right now it's the data from the research area, from the experimental that we carried out almost for 2 years. And this is way better right now. The machine right now is in operation. So the operational efficiency at that time in field conditions, but not really operational conditions with all the logistics involved in a real operation, was 46%. And the machine availability at that time was close to 80%. So we were planting on a specimen of 3.5 times 2.3 meters, and we were able to reach 30% of the productivity time on that case back in 2019 and 2020. Today, the machine is on the go. So the costs that I'm showing right now, the economic information that I'm putting right now is back 2019. So take care of those numbers, because the diesel price is completely different than today. The diesel price 2 years ago or 1.5 years ago is maybe half or lower than half of the price that is right now. And also for the lubricants, and for us in Brazil, the real currency to the dollar exchange rate is completely different. So back in 2020, the cost per hectare using this technology was close to 500 euros per hectare, or 290 euros per hour. But take care, the numbers should be quite different today, including the depreciation cost and the interest rate. So the economies in Brazil, and certainly in the globe, is a little bit wavy right now. So be very cautious with this number. And today, the machine on the go is working on real operational scenario, and it's doing close to 1 hectare per hour. And if you consider the operational planting productivity without reseeding loadings, we can reach up to 900 seedlings an hour. But this is not real true, because we have to go and stop every 600 seedlings, reload, and do it again, the operation. So if we consider the seedling reloading, we touch close to 800 seedlings an hour on real site conditions. I will try to show you the video. I don't know if it will run properly to you, but the video will be on the web for you. Maybe the image will be images, not the videos, not a video. So this is the real scenario today. This is one commercial plantation. You can see the debris on the ground. You can see some stumps. You can see some logs, and you can have an overall illustration of the real machine working and planting. I think you are not able to listen any sound. The music is playing, but the idea is to see and to show the overall soil quality, debris distribution, and the reality. So this is what is going on in Brazil. This machine is not a prototype anymore. This is commercially available here in Brazil, and certainly we can deliver this technology to all the world. And I link this technology with our silviculture mechanization index survey. So our group is providing this information during the last 4 years, and this edition 2020-2021 is in English. So Ola, you were going to be able to read our index this time, and I brought the connection to the planter and the triple planter. So in Brazil, this is totally actual, real data. It represents 50% of the, more than 50% of the Brazilian planted forest. And if you take a look here on the planting, we are still in a large majority in 2020 planting with the manual operation. So more than 50% of the total area is planted on level 2, and level 2 means some devices with mechanical action, and level 1 is without any mechanical action, but both are manual operation. Luckily, some companies are pushing the mechanization of the planting operation, and you can see here the level 5 of mechanization. So the planters, the mechanized planters is showing up, is popping up in Brazil. So the forestry companies and the industry side are working hard to shift this manual planting maybe to be as we have for the soil preparation, where we have the mechanization on the go with more than 85% of the area worked with tractors. And if you take an overall view, the general mechanization level, considering all the silviculture operations in Brazil, for eucalypt, we are with more than 40% of the area mechanized. And moving, Ola, luckily for your innovations, we are moving for some level of autopilot and auto guidance. And luckily, we have working right now 0.14% of the area with automation. So certainly in 2024, when you came with your robot, this number will be higher and will be right on time to deliver your technology to Brazil. So coming up to the end of my presentation, just a taste of the numbers. This book represents 50.5% of the Brazilian planted eucalypt and pine, and our machines in terms of tractors are close to 2.5 thousand tractors. 33% represent, or 33% of the machine fleet belongs to forestry companies, and only 4 manufacturers have 83% of our market. So if you want to get more details about those numbers, please check online over ipaf.pr/publicações or publications in English, and you will have the full book in Portuguese and English, and this is free for your download. So Ola and Angelo, thank you for your time. Audience, thanks for the time you spend with me today, and I will be ready for your questions right on. Thank you.
Thank you very much, Saulo. And we have quite a bit of questions in the chat here, and some have been responded already to, and some are still unresponded. And I will start with a question to the first presentation, which I will answer myself, and that is from Benjamin Engler, and about if we are planning to remote control forwarders in the future. And as I said, for this concept that we showed for autonomous forwarding, that is not a prototype, but of course, development that we might see is that part of the forwarding work could be semi-automized. And for those of you who attended the Coffee Formac conference a couple of weeks ago, there was a presentation from one of the SLU PhD students, Mikael Lundbeck, who presented a simulation study on how such a system could be set up, where you have remote control over the forwarder and the operators is guiding the forwarder when it's loading and unloading. So the driving is done by itself, and then the operator is controlling different forwarders when it is needed. And the simulation looked at how many machines could an operator manage given the conditions we had in that study, showing that, if I remember correctly, seven operators could manage 10 machines, for instance. So those kind of things could be the outcome of this, but we are not actively working towards remote control, but that is of course the outcome that could come from this when we have functionality that is possible and available. And there's different reasons for why you might want to have remote control. And we had in the presentations in the second webinar, we had some examples of these kind of aspects in remote control. So you can go back and have a look at those presentations, or contact some of those presenters also if you're interested more in those aspects. So with that, I would like to go to a next question. There was to Erik and his presentation. Maybe you can expand a little bit about what you said about this standalone solutions and this kind of available solutions that could be adapted.
Yeah, if we talk about the integration platform, it's of course something that has been developed inside the program, inside the alliance, so it is tailor-made. It is, however, open source, built on open source components, and the intention is to make it an open platform for other players in that ecosystem to potentially integrate with in the future. Now, because it's developed in the program, it's owned by the consortium and the client, LKAB in this case. But certainly they would be open to discuss how they thought and the structure of that and the architecture and so on. Because the long-term thinking is to expand this in the mining industry, but also to potentially be able to connect value chains, related value chains to the mining industry future on. So I don't think it's possible to straight away start talking about integrating there, because it's two separate value chains. But certainly the concept and the architecture and the open source tools used and the approach to making it happen is something that I'm sure the consortium and the client and us would be happy to talk about with the right interested parties, of course.
Thank you very much, Erik. And I think we might come back to those kind of discussions later on. There's a lot of interesting things there. But I will continue kind of distributing the questions to the presenters here. So the next question is to you, Saulo, and that is regarding tests with other kind of machinery, with tire tractors, for instance, or forwarders. Maybe you saw the questions, or do you want me to read it out?
No, I can see the question, but maybe you could read for the audience.
Yeah. Are you considering tests for the Komatsu Brachy planter in a tire tractor as a forwarder, or a regular tire tractor, in order to have a better cost in maintenance and lower fuel consumption?
Yes, Jula, thanks for the question. We did consider that on the first phase, and the Brachy manufacturer did not have at that time, and I believe they still doesn't have any planter head for forwarders or tired tractors. So they do not recommend us to move for those two base machines. They tried it in the past and the performance was not good. So right now, we didn't have a chance. They don't have the tool. And I doubt they are considering this technology for light tractors or heavy tired tractors or even forwarders, Ola.
Thank you very much for that. And we can continue. We thank Gustavo de Muner for the question. And we can continue with a question regarding the plantation, which is a really tricky one. It's one thing to automate something when you would handle logs that are not that sensitive, but plants are very sensitive. So we have a question from Ricardo Fuentilada about if you have observed differences in first year survival of the plants that you are planted with the different technologies.
Is it for me?
Yeah, that is for you, Saulo. The different kind of planting technologies, have you seen different survival rates?
No, actually at the beginning, for the very first phase, when we were comparing the manual planting or semi-mechanized planting with the first Brachy planter head, we did suffer with the survival rate. It was lower for the mechanized header or the mechanized planting. But then we shift or we design a different a project with them, and then the machine was fully adapted for the Brazilian conditions, Brazilian soil type. So Gustavo, right now, we cannot see any difference from the mechanized planter head from the manual or semi-mechanized planting systems, okay?
Thank you very much. And I will continue with some questions towards our machines, but I would like to pose a question. I have a little bit difficulty writing and coordinating at the same time, so I will orally put a question to Erik and Martin that you can think about while we are talking about another question. That is, if you have any advice for forestry, you had some of them in the presentation, but there is quite a lot of things. But if you would kind of try to narrow down, what would you think would be the best advice to forestry to focus on when we are right now, or what kind of things do you think we might easily forget if we just continue without having some kind of help from your kind of experiences? So I will come back to that after the questions regarding the vision system. And I see that I have my colleague Håkan Lideskog here, so maybe you can turn on your camera, Håkan, if you're presentable, and tell us a little bit more about the vision system and the neural network and such things. And we also have a question is if there is possibilities to kind of help the collection in a strategic way.
I'm sorry, is it my mic or is it someone else's?
Now it's okay.
Can you hear me?
Okay. Yeah, now it works fine.
So I started answering a bit, or hello everyone, I'm sorry. I'm Håkan Lideskog working at Luleå University of Technology in collaboration with Ola in our IUFRO collaboration. So one of the questions was how about the detection itself. So we have been training a neural network. So we have been training a few thousand images and are using that neural network in real time. So we're detecting in RGB data where the logs are situated, and then we're calculating as we know the position of the logs in that data. We know the position in the RGB data, and we can correlate that to the depth data and put a GPS point, since we know all the, so to say, coordinate systems on the machine. And at the same time, we know where the machine is situated in absolute terms. So when the machine is driving forward, we can keep track on where the log is in an absolute position, and then ensure that the crane also can see or know where the log is situated. And can you remember me, Ola, what was the next question?
the question was if there is some kind of possibilities for a strategy in to collect, curate, and label data.
Yes, and that is a very good question, because that's very time consuming, as we have also found out the hard way, because we have been labeled a lot of images ourselves to make this one work. So I think some kind of collaborative work is needed in order for us to have a, for example, there's a lot of efforts having open data sets in other industries like the automotive industry, or in health and Medicare and things like that. And I think that would be a way forward for, I mean, the guys working out in the forest today, and the technology industry working in forestry, so they can somehow collaborate and get this data sets done, because that's a very crucial part of the detection, finding out what's around the machine. So for me, that's a key part in automating these kinds of things in forestry.
Yeah, and I can compliment also. We thank Philippe Giguère for that question, and I think that the environment itself will be very challenging, but there might be some help from other industries or other interests in that thing. But to find logs, we are quite alone with that thing, I would say. But it might be time to think a little bit more about how that could be set up, because we have the harvesters, for instance, that are already making data on what logs are in terms of assortments and length and other kind of things. And if we can complement that with some kind of camera sensor or other kind of sensor that really catches that too, then you have a supervised system that could collect and do that in the normal operations. So it could really be set up, and they have the systems for collecting that data together with the production data that is used. So that is definitely something that should be looked into more. And this is a little bit why we wanted to do this demonstration, to push it forward, to see what would we be needing in the next steps from here. So it was a really good question that we need to think more about. So thank you, Philippe. So to Erik and Martin, your question was about what kind of tips would you like to give us?
Yep. So before we dive into Martin, we'll probably give some more answers, but just a comment on what you just said about the vision, the sensors rather. I mean, it is of course different, but it's not totally dissimilar from the situation on a fighter aircraft. And then, you know, one of our business, our business is owned by the Saab company who manufactures aircraft, fighter jets, and this is a situation where we are also working with them. We have to capture various type of images or vision input, and sort of sensors and sensor fusion to interpret various type of inputs, whether it's images or it could be different type of lidar and so on. So there's maybe, I'm just saying, that's going to be interesting to see the differences and perhaps similarities in learning. And we're also working with trying to create autonomous vessels, smaller boats, which will, the ambition is to build something which can have a map, know the map, but also see, spot things and patterns on land, and so on to judge where am I on the map, so to speak. So I think it's an interesting topic to explore from different industries. That's my point, I guess, to see how is the envelope being pushed in different difficult industries. That's my point. Sorry, Martin, please go ahead and talk about the answer to the question of specifics for the forest industry.
Some of the specifics, I think I would. The first thing that comes to mind is that for forestry, I think you really need to identify a couple of very clear use cases of where you think autonomy will add value compared to manual operations. We have seen value in a rather strange shapes sometimes in different applications. It can be that suddenly a mining company can run on one shift, more or less, then only have two people during nighttime and still have 24/7 operations. We have seen that decreases significantly on both vehicles and infrastructure when in autonomous mode. We have seen that it's an excellent thing for evening out flows, production flows, which for forestry could then be, of course, pulling out logs to the roads for a truck to pick up, for example. I would say that understanding your ODD would be crucial, and initially, definitely you should focus on the simplest ODD you can find, because it's going to be very difficult anyway. If you could find that nice forest without too dense undergrowth and not too many stones or wet marshes or whatever, that would be extremely helpful. But not only that, I think one of the key challenges for you, which is very similar to other applications, is of course if you can operate in an area where you know that you will not have vulnerable road users or unprotected people that have not been trained or does not have any equipment. If you have forests which are maybe fenced in, or if where you know that people are not strolling about, that would help you tremendously from a functional safety perspective. I would also start really initially to think about the business case and how to set that up, and because we see that initially some companies are pursuing lock-in effects with their customers. They want to develop a complete solitary system, which if the customer buys it, they will be more or less forced. They will lose their buying power. They will need to continue buy from the same partner every time, and instead actively pursue some kind of partnership between the major players in the industry. So you can create open standards for communication. You can create open standards for how to control the different vehicles. The lock-in effects will greatly benefit the equipment manufacturers and not maybe the forest companies. Some thoughts on the subject.
Thank you very much, and it's very helpful to have these kind of expertise and experience to share, and I think it is very crucial. Of course, we can as researchers continue to do things for the fun of it, not really for the fun of it, but to develop things, but to really make it operationalized, we need to do it in a way, as you say, we need to have a good case where you can see some benefits from an industrial setting, etc. So I think that's very good input from your part. So thank you very much. And let's see, Angelo, I don't see that there are any unanswered questions in the chat, as far as I can understand. If there is someone who still have one question or so, you would be happy to let me know.
I think so, Professor. I just have one comment here, a general one, regarding the whole context of automation. We are getting to the end of these 3 sessions. We are very happy about the very productive, interesting discussions, and to see many advancing, not just in forestry, but also mining and other sectors. And we see that this seems to be like futuristic, but we already seen many interesting things happening right now. So the future is coming gradually. It's not something that we will see maybe in 10, 20, 30 years, maybe some full autonomous, yes, but there's a lot of new technology that is being implemented gradually. The innovation works like that in most of cases. So I just wondering, my only comment here, I would like to also to lift up this discussion maybe for the next opportunities, is how we can use the advanced technologies that that are very far from our operations, from our reality today, to bring it to the real world and try to use this kind of technology, like for a partial automation, as like I said for the forwarder, as I asked about the forwarder, like maybe try to involve or engage the manufacturers and try to bring like the sensor cameras for the common forwarder to help this forwarder load and load autonomously, and even having an operator like the planter head works. There is an operator inside. he need to maneuver, but all the job happens autonomously. So just wondering about that. I think I just used the example of water, but I think we may use this example and try to explore, maybe like Erik mentioned, trying to have a collaborative work between different parts and try to speed up this process, maybe trying to bring all those sensors, these technologies for a medium term using in a partial automation. That's my thinking about it. And just would like to thank you everyone for being here, for your time, and for the speakers, and also Rafael and Ola that has organized this event together with me.
And thank you to you, Angelo, who has done all the hard work with the coordination. Thank you very much. And we hope to have the possibility to make a follow-up series. So if you have any suggestions, or if you would like to give a presentation or have themes for presentations, please feel free to contact us via email and send those suggestions, and we will try to get back to you to see how this proceeds. So thank you very much, everybody, and have a good night, evening, or morning, wherever you are.
Thanks, everyone.
Okay.
Bye-bye.
Everyone. Bye-bye, everyone.
Ciao, Angelo.
Ciao,
Thank you all. Bye-bye. Bye-bye, Angelo. Bye-bye, Professor Saulo.
Tchau,
Bye,
tchau.
Sandro.
Obrigado, Sandro. Um abraço a todos. Bye, bye.
Abraço.
Bye,
Bye.
all.
Tchau, tchau.
Hello, Marcos. How are you?
É o Marcos ali, o Marcos Vicker. Obrigado, Marcos.
Yeah, I'm fine, thanks.
Thank
you guys. Very good to see you again online. Hopefully we have something in person in the near future.
Yeah, we're
Great.
expecting to. Thank you for your comments, and hopefully you can read the PC Math Mechanization Index, and that
Very
is
happy to see that one.
Yeah, and it's a fruit from your work and Angelo's work. Certainly, you two were the key guys to make it happen right now.
No worries. Very good. Cheers, guys. Bye.
Cheers.
Bye-bye.
Bye-bye.
Ciao.
Bye-bye.
And it's fascinating to see that, Saulo left us now. But the silvicultural part, the planting part, that is, even though we are so mechanized in the Nordics, I think those numbers would be the same here with the plantation, the manual plantation. Same